morning, friends and dear students. I am here again for my course Aircraft Systems. Today I am in lecture number 30. The topic of this lecture is fuel systems, characteristics and components. So I am going to discuss about the aircraft fuel systems and what are the characteristics of the fuel and different types of components used for this. Before I start this topic, I should again say that I am in module number 4. Before I complete this topic, I have already completed module 1, module 2 and module 3. In module 1, I have started with 4 pillars of aircraft systems. The first one is airframe system, second one is aircraft vehicle system, third one is avionics system, and fourth one is the mission system. If I talk about the airframe system consists of wing, fuselage and the empennage. The vehicle system consists of electrical system, electrical power generator system, navigation system, your hydraulic system, pneumatic system, and these all the systems are covered in my module number 2 and module number 3. In module number 4, it is basically related to the engine and the fuel control. So I am in between the module number 4, and you know that the today's topics I will be discussing about aircraft fuel system, then introduction, fuel system types, small single engine aircraft fuel system, jet transport aircraft fuel system, helicopter fuel system and aviation fuels. These I will be discussing in detail one by one in my next topics. So in the previous class I have covered evaluation of the engine control system, limited authority control system, in which I have explained about hydromechanical control system which was used in olden days, but now most of the engines are using full authority digital engine control system. It is called FADEC, and its advantages and the disadvantages, and also how this FADEC is operated and how this thing is sensing. These all things I have discussed in my just previous class. So here aircraft fuel system, I will talk about the introduction of the fuel system. And if you see here, an aircraft fuel system allows the crew to pump, manage and deliver aviation fuel to the propulsion system and auxiliary power unit, that is called APU of an aircraft. Fuel system differs greatly due to different performance of the aircraft in which they are installed. Now each aircraft fuel system must store and deliver clean fuel to the engine at a pressure and flow rate able to sustain operation regardless of operating conditions. So every fuel system, first thing is that it should be able to store sufficient amount of fuel, and also it should be able to deliver the clean fuel at all conditions of the operating condition of the aircraft. So these are the two things which any system has to perform, and this any system has to do. And it also ensure that there is a required pressure and there is a required flow rate. This has to be maintained in whatever conditions may be. This flow rate and the pressure of the system has to be maintained. These are the requirement of the system. Now, if I talk about a small single engine aircraft fuel system, in this we have the gravity feed system, then we have the pump feed system, and then we have the high wing aircraft with fuel injection system. These are for the small single engine aircraft fuel system. Now, we will talk about the gravity fuel system, a very basic system of the fuel in which the flow is happening with the gravity of the earth, and fuel will go by the help of the gravity. So gravity feed system, in this, with the tank above the engine, in this condition, with the tank above the engine in aircraft wing, gravity is used to deliver the fuel. The space above the liquid fuel is vented to maintain atmospheric pressure on the fuel as the tank empties. The two tanks are also vented to each other to ensure equal pressure in both the tanks feed the engine. A single screen out on each tank feeds lines that connect to either a fuel shut-off valve or multi-position selector valve. The shut-off valve has two positions, fuel on and the fuel off. So here you can see that a very basic. Here is the right tank. Here we have the left tank. Here is the one gauge is there. It is on and off. It is a shut-off valve. It can make on or off. Then we have a strainer or the filter. From here it goes to the primer. Then it goes to the carburetor. From the carburetor, fuel goes to the engine. Here is a vent. So this vent is very much necessary. And here we have the fuel selector valve. So this is a shut-off valve or the fuel selector valve. So here the blue color shows the fuel supply line, and it goes to the carburetor, and from the carburetor is go to the engine, especially piston engine. Okay, so this is the basic gravity feed system of the any aircraft. Now, next one is the pump feed system. In this, gravity is not required. By the pressure of the pump, fluid is supplied to the aircraft. So here, low and mid-wing single reciprocating engine aircraft cannot utilize gravity feed, because if the fuel tank is below the engine, then we cannot use. So mostly the fuel tanks are on the aircraft. So if the aircraft wing, and if the wings are mid-wing or the low wing, and engine is little above the wing, then gravity feed system is not sufficient and it cannot work. So in this type of situation, like low and the mid-wing single reciprocating engine aircraft cannot utilize gravity feed fuel system, because the fuel tanks are not located above the engine. Instead, one or more pumps are used to move the fuel from the tank to the engine. Since fuel is not drawn from the both tank at the same time, there is no need to connect the tank vent spaces together. From the selector valve, or left, right or off, fuel flows the main strainer where it can supply the engine primer. Then it flows downstream to the fuel pump. Typically, one electric and one engine driven fuel pump are arranged in parallel. This you can see here. If the fuel tanks are lower than the engine level, so carburetor is here, we need one electric pump, plunger type or any type of electric pump. From here, the fuel is here, fuel tank, left and the right, and it will suck from here. Fuel will go to the filter. From filter or strainer, it will go to the pump. From the pump, the high pressure, this will go to engine driven pump diaphragm type, and it will go to the carburetor. From the carburetor, it will go to the respective engine. So this is the feed pump feed system, and previously was the gravity feed system. So in this, we have the high pressure zone by the red, and this is the blue. It is a low pressure fuel supply. But after the pump, the pressure is high. So here we have the engine driven pump diaphragm type. This is the engine driven pump, and this is the electric pump plunger type. So there we have used two types of pumps, and they are supplying a high pressure to the carburetor. Now, high wing aircraft with fuel injection system. So the high wing with fuel injection system, how these things are happening. So this you can see here that these are the tanks, left tank and the right tank, and they are above the carburetor or the injection, and here is a vent check valve, here vented caps, then here we have the fuel reservoir, then here we have the selector valve, it selects, then we have the auxiliary fuel pump, then we have one fuel strainer or the filter, here is a 2 intake manifold, and from here it goes to the engine priming, then engine driven fuel pump is here, from here it goes to the fuel injection control valve, and from here fuel goes to the fuel flow indicator, from where pilot will see that fuel flow is there or not, and then it goes to the fuel injection distributed manifold. So this you can see there are number of fuel injectors, and these are spraying the fuel. So a high pressure is required, and in this type of the high wing aircraft with fuel injection system for a piston engine aircraft is used like this. So some high wing with high performance single engine general aviation aircrafts are equipped with a fuel system that features fuel injection rather than the carburetor. So normally if you see that if you are using the ATF fuel, this fuel I will be discussing in my next chapter about the fuel characteristics and the quality of the fuel. So there we don't use in gas turbine, we don't use the carburetor. So we use the injectors, and these injectors are spraying with a very high pressure. So it combines gravity flow with the use of a fuel pump. So in this, gravity and the fuel pumps, both methods are used. Now I will discuss about jet transport aircraft fuel system. And in this, till now we have discussed about the piston type or the reciprocating IC engines, but now here a jet type of aircraft fuel system and how these things are working. A jet transport fuel system can be regarded as a handful of fuel subsystem as follows. It should have the storage, it should have the vent, it should have the distribution, it should have the feed, it should have indicating system. These systems should be present. So here we can see here a jet transport, a one passenger aircraft. So here we have the tank here in gallons, left main tank. So in gallons 9560, and in pounds if you see 64,000. Main right tank. So it is a left main tank. Just you can see this is the left main tank and this is the right main tank. RMT, LMT. Okay, just I am writing. Okay, so right main tank, same quantity. Center tank, this is the center tank, this one. In this we have the 26,100 gallons, and total we carry 45,200 gallons or 302,900 pounds. This much quantity of the fuel is stored in this. So this is the Boeing 777 fuel tank location and the capacity. It is shown here. It is for your knowledge that you should understand that Boeing 777 will carry 45,200 gallons of the fuel. Okay, that is very much, very huge amount of fuel is carried. Now I will talk about the fuel vent system of the turbojet engine, and in this you can see a very nice diagram how this venting of the fuel is taking place. So here if you see different locations are given. Here this one is the check valve, this one. Then here if you see this is the check valve type 2. These are the two check valve. Then if you see here we have, this is the float valve, normal vent. Here we have the float valve in this. Here also this we have. Then we have vent scoop and the surge tank. Then we have upper surface seal stringer, and then we have the deflector here. Same way here we have the climb vent. This is the hole here. This is the drain hole here. This is the drain hole. Then here we have the crossover tube. So it is making to connect two things at a time. Here we have the check valve, this one. Then we here APU fuel line shroud, APU fuel line shroud. This is the drain, and these are the check valves. And here, if you see, this is we have the valve stop here, O-rings, vent, wing tank, float valve. So this just I have given a representation of different types of parts which are used in fuel tank vent system. If you see another one is a fuel distribution system. Very complicated systems are used, and here if you see we have the yellow system, blue system, red system, and in this aircraft, especially the DC-10 airliners, we use this type of system. I am not going to go in very much detail about this, but it is just shown for your viewing purpose only. So now I will talk about the helicopter fuel system, and you know the helicopter is one of the very simplest machine, and it has got the tank, and from the tank, as you can see here, this is the tank here. Here we have the check valve, we have here the pressure switch, then we have the thermal relief valve here, then we have the here vent line. It is making sure that air is made out. Then from here it goes to the filler cap. Then it is the shut-off valve. It is making on and off of the system. Then it goes to the airframe filter. Then it goes to the carburetor filter. Then engine-driven fuel pump is here. Then it goes to the transducer. From here it goes to the pressure differential switch. And here is the restrictor switch. So like this, it is used for a different types of. A simplest helicopter is using such type of fuel system. Okay, so here this you can see another type of system, which is here a fuel tank. Here you have the vent line, then you have the filler cap. So from here we put the fuel inside by some fuel tank or bowser of the different companies. Here is a strainer. This strainer is filter. Here we have the sump drain. We want to drain the last of the fuel, because at the last the sediments are concentrated. So we have to remove that contaminations, maybe water or some impurities, because the impurities is and the water both are heavier than the petroleum product. So ATFK or the kerosene or the this gasoline which we use, so it is accumulated at the bottom. I mean, this is used for that purpose. From here it goes, we can take the sediments here. Here gas collector is there, and from here it is carburetor, and from here it goes to the engine. So these are the two systems which are explained here for simple gravity feed helicopter fuel system, and this one is a pressure feed fuel system on a light turbine powered helicopter. So this is the simplest one, gravity feed, and this one is the pump feed. And just I have explained you that if the tank is below the engine, then we have to use the pump feed system, and if the fuel tank is above the engine, then we can take the gravity feed system. Now I will talk about the fuel tank. Fuel tank is a safe container for flammable fluid. Though any storage tank for fuel may be so called, the term is typically applied to part of an engine system in which the fuel is stored and propelled fuel pump or released pressurized gas into an engine. Aircraft typically use three types of fuel tanks. One is integral, another is a rigid or the removable, and the bladder. Here it is shown all this integral, or it may be the removable, or it may be the bladder. Fuel tank inerting system. Inerting means we are making sure that this is not going to take fire. An inerting system decreases the combustion or flammable material stored in a confined space, especially a fuel tank, by maintaining a chemically non-reactive or inert gas such as nitrogen in such a space. Inerted fuel tank may be used on land or aircraft. So we use some special type of gas, which is inert gas. This inert gas is trying to make that fire should not take place, because if the fuel is there are a lot of vapors, and these vapors, if little mistake or small fire or small spark is there, so it may take the fire. So to prevent that, we have to make some inerting system so that it is safe from the fire. Three elements are required to initiate and sustain combustion: and ignition source, that is the heat, fuel and oxygen. Combustion may be prevented by reducing any one of these three elements. If the presence of an ignition source cannot be prevented within the fuel tank, then the tank may be made non-ignitable by reducing the oxygen concentration. So how we can make? Reduce the oxygen, then reducing the fuel, and then increasing the fuel concentration, nitrogen, air or CO2. So this inert gas, if we increase, the fire prevention can be taken place. Now I will talk about aviation turbine fuels. Just I told you that different properties are this aviation turbine fuels are there. So here we have to go inside into the aviation turbine fuel. It is called ATF. So aviation turbine fuels or ATF will be covered in the following headlines. These are the topics which I am going to cover in this introduction: aviation turbine fuel, then fuel contamination, and present quality checks on ATF can be carried in the field. So introduction to ATF. What is aviation turbine fuel? ATF means what? Aviation turbine fuel. So what is that? ATF is a specialized type of petroleum based fuel. ATF source of energy and power most of the modern generation aero engines, jet engine aircraft. Importance of ATF: aero engine has to function within predetermined parameters within a specified altitude and the flight speed range. Hence, fuel has to be of consistent quality and airworthiness. So, the quality of fuel should be very good, and it should be able to sustain in air. It should be able to fly very nicely. ATF acts hydraulic and lubricating medium for fuel equipments. So, ATF also acting like a hydraulic fluid or the lubricating medium for fuel equipments. Fuel equipments, it can work as a cooler also. So, properties of the ATF. Important performance properties of the ATFs or aviation turbine fuel is energy content. It should have a predicted by a fuel density. So, how much energy it is carrying, how much calorie of energy it can sustain, or while burning up the fluid, how much power it can generate. This is dependent upon its density, and so density has to be very consistent. Combustion characteristics, that is, combustion is continuous in a jet engine. Next important topic is stability, whose properties remain unchanged: storage stability and thermal stability. So, storage and thermal means once you are keeping in the tank, it should not deteriorate. It should not chemically decompose. It should maintain the same density at a long time of storage. Thermal stability, at the different temperature of atmospheric, it should maintain its density, it should maintain its properties of combustion and the energy constant. Then is the lubricity. Lubricity is the ability to reduce friction between solid surface. So if fuel is going with pipeline or some pumps, it should also give some lubrication property of the system. So next is the fluidity, ability of a substance to flow, viscosity and the freezing point or the physical properties. So fluidity also should be there. Means at a low temperature, it should not become very viscous. So a proper amount of viscosity is required at all type of given operating condition. Then volatility, it is a fuel tendency to vaporize. So it should not vaporize very fast. That is the non-corrosivity. So non-corrosivity. So your fuel, when it is going through the metallic pipe or any type of rubber material or all, it should not give any chemical reaction, and there should not be any corrosion or any rust should not form if the fuel is used. So these are the some important properties of the any fuel system or ATFK or aircraft turbine fuel. Now Jet A1. So major civil and the military jet fuel. So these are the civil fuels. Okay, means not for military. So here we use the Jet A1. So most widely used fuel for jet engine, it is called the Jet A1. Flash point minimum of 38 degrees centigrade. Freeze point maximum of minus 47 degrees centigrade. So this is the Jet A1. UK specification of this is DEF STAN 9191. This is the same as a Jet A1. UK has given this name as a DEF standard, Defense Standard 91-91. Now Jet A, available in USA only, has same place point of 38 degrees centigrade, but a higher freeze point, means minus 40 degrees centigrade. Here it is a minus 47, but here is a minus 40 degrees centigrade. Here ASTM D is 1655 Jet A specification. This is the name of Jet A specification. These numbers are given. Now Jet B has higher flammability, alternate to Jet A1 as used in cold weather. So if you want to use for a cold weather, then you have to use this Jet B. It gives more minus temperature, so it can be used for a very low temperature condition. So these are the civil jet fuels. Now I will talk about the military jet fuels grades. Though it is called JP4. This is the equivalent to Jet B with addition of corrosion inhibitor. We use some corrosion inhibitor so that corrosion should not take place. So it is called JP4. Now we have JP5, high flash point kerosene used on aircraft carriers. So in the aircraft carriers in the Indian Navy, we have the aircraft carriers. Previously we used to fly the Sea Harrier. Now we are using the MiG-29S. So these aircraft use the JP5. In this it is some corrosive and it gives some anti-corrosive and it gives some better efficiency. JP8 is military equivalent to Jet A1. So these are the military aircraft: JP4, JP5 and JP8. So this we have to, if you are in the military or in defense forces and you are the aircraft maintenance engineer, you have to make sure that these JP4, JPA5, JP8, there is an equivalent of this thing in civil also. So if you are in the civil airport, you may not get the same what you want, but you should know that which one is the equivalent to JP4. If your aircraft is using JP4, so if you see here, it may be Jet A1, Jet A. So as per that equivalent, you have to use the fuel as per the requirement. Now, specification of ATF. Product specification is a mechanism by which producers control the property necessary for satisfactory and reliable performance. The major jet fuel specifications are, these are the international specification. First one is ASTM D1655, US specification for 3 commercial jet fuel, Jet A, Jet A1 and Jet B. It is called ASTM D1655 specification. Then Defense Standard 91-91, it is a UK Ministry of Defense maintained this specification. GOST 10225, this is the Russian specification. Joint checklist, group of oil companies have combined the most restrictive requirement from ASTM D1655 and DEF Standard 91-91. So this is the companies which are producing the fuel, ATF, these are maintaining joint checklist and they are combining ASTM D1655 of USA and Defense Standard 91-91 from UK. So this has to be clubbed, and this we should understand that what is the meaning of this. If anyone is telling that ASTM D1655, you should understand that this is the US specification, and in this we have the Jet A1, Jet A and Jet B. If anyone is telling that it is Defense Standard 91/91, then it is a UK Ministry of Defense specification, and this I have the equivalent of ASTM D. Third one is the Ghost, which is from the Russian specification, and then we have the joint checklist, and which is from oil companies. They produce as per the both the ASTM D1655 and Defense Standard 91-91. Here I have to mention some fuel properties and it's significant. I have here given Indian specification, that is Indian standard number 1571 and 2001. It is the 7th revision. If you see here, we have the characteristics. Appearance, it should be clear, bright and visually free from solid matter. This you have to see. Then compositions, we should have acidity, then okay, how much it is 0.015. Then we should have the aerotic percentage of the volume. Then we should have sulfur, and then volatility. It should have final boiling temperature 30 degrees centigrade. Then loss percentage by volume maximum is 1.5. Then fluidity, freezing point minus 47. Then dynamic viscosity 8.0. Then if you see the combustion properties, specific energy, it is equal to 12.9. Smoke point, it is 26. Corrosion, it is not. Then these are all are the parameters are given only for your the reference. ATF, how much it should contain. Now I will talk about the fuel contamination. Every transfer of ATF from refinery to aircraft occurs. There is a potential for contamination of the fuel because it is from one place to another place. Number of places it is uploading and the downloading. So there is some chances of mixing of some unwanted elements. So we should make sure that when we are using on the aircraft, it should be within a specified limit. So particulate matters and waters are the most common. So these are the particulate matter, another is the water. These are the two parameters which are making the system contamination. Why fuel contamination is critical? Aero engines, fuel system has a very precision calibrated orifice, fuel atomizer as a component, fuel burner. The contamination in our ATF will affect stable engine operation. Then ATC contamination. So fuel contamination occurs due to fuel transfer from refinery to the bulk petroleum installation. Each time fuel transfer, potential chance of fuel contamination. Particulate matters and waters are the most common fuel contaminants. So what are the particulate matter? Dominant source is solid corrosion. So, because it is some rust will take place and this rust will move with the fluid. Airborne suspended particles. In air you have some dust and all. Solid from microbial infestations. Refinery processing materials, catalyst and so many things. These may be used as a particulate matters. It may be present in the fuel. So we have to make sure that these particulate matters should not be present at any cost when we use on the aircraft. Water contamination. Water comes in from humid air, rainwater and due to condensation, because in the way air itself water is there. As you go in higher altitude, water will be condensed. So water occurs in the three form: dissolved water is slightly soluble in ATF, which increases its temperature water dissolve increases. ATF contains between 40 to 80 ppm dissolved water at 21 degrees centigrade. So ATF will have 40 to 80 ppm. Okay, so that we have to make sure that this water should not be present more than this. Free water exists as a separate liquid phase with influence of gravity form a lower layer of the fuel tank. So if you see that if you put in the fuel tank, at the lower water will be accumulated. So as and when you go for the flying, before that you have to drain out. There is a drain and you just press it, half liter or 1 liter you have to remove it. Mostly in that 80% will be the water, and this water you can remove it. Particulate contamination, we have the surface taint. So polar organic compounds can stabilize a fuel water emulsion by reducing the interfacial tension. Then we have the microbes. Microorganism found in fuel includes bacteria and the fungi. Solid formed by the biogrowth are very effective at plugging fuel filter. Quality checks on the fuel, we have to make sure that our quality of the fuel is also to be maintained. So what are the checks we have to do? First, we have to do the visual checks. We have to see from a glass, just it is shown here. To check visibility, ATF sample is clear and bright, and also for any trace of sediments. Then density check, to check the density of the ATF. So how we will do? Just I will show you here. Very simple method is there. We will have here 3 tubes. So one is here. This is the test tube. Here is the 5% and here is the 10%. So we all will put, there is a ball here, a steel ball. We have to fill this by this one, by the aircraft tank fuel in this, the center one. And here we have the 5% of the contamination. Here we have the 10%. And if we turn it upside down, this ball will move. We should make sure that this ball should not go above 10%. Means this will move faster. This will go here and this should be here. But at no cost, this ball should go ahead of this. If it is ahead of this, then fuel is rejected. Fuel is rejected. We cannot use this fuel for the operation of the aircraft. So that is the purpose we do. Water checks, finding water with help of water detection capsule. Fuel samples from bottom of the refueler tank checked for the water. So there is a capsule. If we open and put that capsule on the fuel, the color of the fuel will be changed from clear to purple or some other color if water is present. So in the next topic, I am going to discuss about fuel systems for aircraft and introduction. Single engine aircraft gasoline fuel system, multi-engine aircraft gasoline fuel system, turbine fuel system functions, refueling, defueling and jetsoning. This will be, I am going to discuss in detail in my next class. I request all of audience, please be tuned for my next class, and it will be very good to understand the basics fuel systems of aircraft for different type of aircraft. References, I have taken the Moyer and the Seabridge aircraft systems, mechanical, electrical and avionics system. This is from Professional Engineering Publishing Limited, London, and Bury St. Edmund, UK, ISBN 1860582893-2001. Another book is from Moyer and the Seabridge, again, Design and the Development of Aircraft Systems and Introduction, AIA Education Series, AIA 2004. So if any questions, you are welcome to ask me in this my email, ydwivedi@gmail.com. So in this, I am going to, you can ask the question to me, and thank you very much for the joining. I further request to subscribe my channel and also like it. And if any query, you can put your comment. I will be trying to solve your problem. Thank you very much for the joining. Be tuned for the next YouTube video. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.